Hey everyone, Morgan here. We're on page 17 of the bonding outline for AP Chem, and we're now going to be taking a mathematical look at the idea of lattice energy. So this is a whole lot of Hess's law problems. It's a slightly different set of types of reactions, but that is what we're doing. Here we've got all 5 of these, and then we have a goal equation. Mg solid plus Cl2 gas to give us MgCl2 solid. That is actually called the heat of formation. And we're going to approximate it using this other information. So the first thing I'm going to need as a reactant is Mg solid. And I'm going to take that right here from this equation, and I'm going to go Mg solid gives me Mg gas, and the delta H naught for that is going to equal 150.2 kilojoules per mole, and these are all going to be in kilojoules per mole. Okay, now the next thing I really need to do is get rid of that Mg gas. So I can do that actually with this equation right here, which is called ionization energy. Mg gas gives us Mg2 plus gas plus 2 electrons, no state of matter for electrons, and that is 2200.3, and these are all in kilojoules per mole. All right, so I also need the Cl2 gas, so I've got that here in this equation right there. Cl2 gas gives me 2Cl gas. It's actually called bond energy. And that delta H naught is going to equal 243.3 kilojoules per mole. I'm seeing stuff's going to start canceling now. Now, I have to get rid of the 2 Cl's, and I'm going to do that with this equation, but I'm going to have to multiply it by 2. 2Cl gas, okay, plus 2 electrons gives me 2Cl minus gas, and that delta H naught is 2 times negative 367.8 kilojoules per mole. And then finally, I'm going to need to get this MgCl solid in there. So I'm going to go with the Mg2 plus gas plus 2Cl minus gas gives me MgCl2 solid. That, the way it's written, is actually called the lattice energy. And delta H naught equals negative 2500 kilojoules per mole. Mg gas is going to cancel. All right. Mg2 plus gas is going to cancel. 2 electrons will cancel 2 electrons. 2Cl gas will cancel 2Cl gas. 2Cl minus gas will cancel 2Cl minus gas. And what does that leave me with? Mg solid plus Cl2 gas yields MgCl2 gas, and when I add this all up, do the arithmetic, I get negative 641.8 kilojoules per mole, which is close enough in agreement with the tabulated values that I'm happy with that, because again, this is an approximation. Okay. Now, let's go on to the next one here. And rather than looking for the heat of formation, which I would be able to look up in tables, I want to look for the lattice energy for this reaction. And that's the much more likely type of calculation that I'd want to be doing. Okay? So, I need K plus gas plus F minus gas to give me Kf solid. I'm going to start off with the heat of formation, which is actually the first thing that's given here. Okay, K solid plus 1/2 F2 gas to give me Kf solid, and my delta H naught for this equals negative 562.6 kilojoules per mole. Next thing I'll do is I'll actually try to get the K plus, and I'm going to have to reverse this equation. So K plus an electron, that's a gas by the way, is going to give me K gas. And then this is going to be a negative 424.93 kilojoules per mole. You'll notice it was a positive here, except I reversed the equation. Then, to get the F minus, I'm going to reverse this next equation. F minus gas yields F gas plus an electron, and that's going to be a positive 349.7 kilojoules per mole. Okay, I reversed the equation, so I have to change that sign. Then let's see. I'm going to need to get rid of the potassium as a gas. So K gas goes to K solid, and that is 90.0, and I reversed it, so I have to put a minus sign in front. Kilojoules per mole. Solid and K solid. Okay, 1/2 F2 with 1/2